We now consider slope of a tangent line. Generally, tangent line is considered to be a line that meets a curve in just a single point. And if this curve is part of a circle, then it's never going to meet this straight line again. Now we want to have such an idea for a function. So say this is my graph of the function, and I'm interested in finding slope of the tangent line at this point, which is at a distance of x. So this point, this height is going to be f of x. So that point is x comma f of x. Now what I'm going to do in order to find slope of tangent line is I'm going to consider a nearby point, and I'm just doing an exaggeration here to draw. So say this point is h units away, and usually h, I want to keep it close, but in order to just show a clear picture, I've taken this point to be a little bit further. Now, if I were to join these 2 points, oh, by the way, this point has then coordinates x plus h, f of x plus h. Now, if I were to join these 2 points, then this line is called secant line. Now, if I were to move this point closer to the old point, x f of x, so let's say I'm considering moving that point here, which means I'm reducing that gap. So now the secant line actually gets closer to the tangent line. Now the tangent line itself will not meet the curve again, but if you bring this point closer and closer, then you get an idea of what a tangent line will look like. So this is the tangent line. The green is the tangent line. The black line was the initial secant line. So let's focus on that black secant line, so this one. And what is its slope? Well, I'm going to use the slope formula. So slope of the black line is y2 minus y1, or it's this rise over run, and this distance is f of x plus h, and this distance is f of x. Oops. So f of x plus h minus f of x over, and this distance, I can see that this is h. That's what we started with. Or I could say it's x coordinate of x plus h and subtract x. So either way, I get that h. So slope of the secant line is given by this. This is simply the difference in y's, the rise, y2 minus y1, and the run is h. Now, if we move the point closer and closer, meaning h is getting closer and closer to 0. So if I want slope of tangent line, then what I'm doing is I'm considering the slope of the secant line, but this time what I'm trying to do is I'm trying to get h as close to 0 as I want. So h is approaching 0. That's how we write. We say limit h approaches 0 of the slope of the secant line. So this is the formula for slope of a tangent line at the point x.